So in previous video I talked about the time dilation, and I showed that this time dilation is also a consequence of Lorentz transformation. So in this video I am talking about another interesting consequence of Lorentz transformation, which is known as the relativity of simultaneity. So basically, if you have two events that are simultaneous in time in one frame, so can they be simultaneous in another frame that is in motion? Let us first talk simultaneous events. So if two events are happening at the same time, so we call these two events as simultaneous in time. Here you can see in figure that we have two light bulbs A and B, and let's say these light bulbs are connected to a single switch. So if you turn on the switch, so both of these light bulb will light up at the same time. So these two events, that is the lighting of bulb A and lighting of bulb B, are simultaneous in time. Also, if you consider this type of setup in which you have a source of light at the midpoint of this box, and then you have two detector D1 and D2. So when the light is emitted along positive and negative direction, so this light will travel equal distance on both sides. So therefore the detection of light by detector D1 and the detection of light by detector D2 are simultaneous events in time. So the idea is that if there are two events that are simultaneous in one frame, so are they simultaneous in another frame that is in motion? So let us write the coordinates. So let's say the lighting of bulb A is the event E1 and lighting of bulb B is the event E2. So I can write the coordinates that are x1, y1, z1 for bulb A, and time t for lighting of bulb A. And similarly for bulb B, I can write x2, y2, z2 and time t, because both of these events are happening at the same time, so therefore they will have the same time. Also for another frame S prime that is in motion, so we can write their coordinates x1 prime, y1 prime, z1 prime and t1 prime. So x2 prime, y2 prime, z2 prime and t2 prime. So idea is that this time interval t2 prime minus t1 prime is 0 or not, because if it is 0, so they are also simultaneous. So if it is not 0, so it is not simultaneous. So we in our one of previous videos, so I derived the Lorentz transformation. So this is basically the Lorentz transformation equation for time. So t prime represent the time in the moving frame, and t prime and simply the unprimed coordinate represent the time in the rest frame. So this is our transformation equation. So I can use this transformation equation to find out t2 prime and t1 prime. So this gives me t2 prime is equal to corresponding time in the rest frame, and you see here in it is t. So t minus x2 v by c squared into gamma, and for t1 prime it will be the corresponding time of event 1 in the s frame, and it is also t. So t minus x1 v by c squared gamma. So I can find the time interval, which is t2 prime minus t1 prime, and this is equal to gamma can be taken as common. So this gives me t minus x2 v by c squared minus t plus x1 v by c squared. So plus t minus t will cancel out, and we will left with minus v by c squared x2 minus x1 into gamma. So look here, so the time interval t2 prime minus t1 prime, which I am calling as delta t prime, is not equal to 0, because this factor x2 minus x1 is not equal to 0. So it means that if we have two events in S frame that are simultaneous and in time, but they are at different locations, that is x2 and x1 are their coordinates. So these two events cannot be simultaneous in another moving frame. So now that is an interesting thing. So simultaneous events in one frame are not simultaneous in another frame. But here if you look that if this x2 minus x1 becomes 0, so this factor becomes 0. So mean that if in S frame two events are happening at the same location at the same time, then these two events will be happening at the same time in another frame. So that is the only possibility for the simultaneity in the other frame. Okay, since now we have found a relation, so though the events are not simultaneous in moving frame, so which event happen first? So in S frame D1 and D2 are simultaneous. So I'm talking about this type of setup that the light is emitted from the midpoint and it travels along the x direction. So since light has to travel the equal distance on both sides, so therefore the detection of light by detector D1 and the detection of light D2 is happening at the same time in one frame. But now in S prime frame that is moving with speed v. So now you see that if the frame is moving or the entire setup is moving along the positive x direction, then this detector D1 has to travel less distance, because when light is originated from the midpoint and it travels and towards D1, so in that time D1 has moved a distance which is given by V multiplied by the time interval. So therefore the light which is reaching at D1 has to travel less distance, and therefore the D1 will detect light first. So therefore D1, this event D1 will be first, and then we will have D2. So that is the idea, that that event which have less value of the coordinate, so that event will happen first if the frame is moving along the positive direction. So if the frame is moving in the negative x direction, so D2 will detect light first. So the order of events are also frame dependent. So in this video I have shown that the two simultaneous event in one frame may not be simultaneous in another frame, and also the order of events depend on the frame from which we are measuring or from which we are making our observation. Also the order of the events are also frame dependent. So that is all for this video.